Okay, so continuing with our study of populations, we're going to move from talking about animal populations to talking about human populations. So let's jump right in. Okay, sort of. All right, so first let's scroll back. So we're talking about human population dynamics now instead of animal population dynamics. And so if we look at our planet here, we can see that this is a little bit dated. This is 2015, but we can see relative populations here. So this is a map based on population rather than really on Earth size. So you can see just how overwhelming the populations of some countries are as compared to others. In fact, you can see how tiny Canada is simply because of its population. And so most of the areas that are growing are these areas here in Asia, as well as some areas in Africa. In most of the US and Europe and in Japan as well, our populations are steady or shrinking. So most of the growth is occurring in what we would call developing nations. So our population these days is about 7.7 or 7.8 billion people on the planet. And we add 1 million people about every 4.5 days. Um, on average, we're growing about 220,000 people every day. So that makes about 4.5 days. So why is our population growing so fast? And why has it changed so much in the last 100 years? Well, it all starts with the advent of agriculture. So 400 years ago, we moved from being a hunting gathering society to a stationary society dependent on agriculture for food. And when we do that, we establish a consistent food source. And so this dramatically changes the human population. And then as agriculture improves, so too improves sanitation and medicine, which decreases our death rate again. So, two major factors, just like for animals, that as long as we have access to ample resources, that our population is going to grow more quickly. And once we start to become healthier and decrease the death rate, then again, that causes the population to increase more quickly. So, those factors that influence human populations. So, we know about the factors that influence animal populations. Let's talk about human populations. So, the population size itself influences the rate of growth of human populations. Also, birth and death rates. So, as we have higher birth rates, that's going to increase populations. Higher death rates are going to keep populations in check. The fertility, so the number of children that each woman has, along with life expectancy, and then migration. So this can be immigration, meaning people immigrating in, or it can be emigration, meaning people immigrating out of a particular country or area. So, 5 main factors. We're going to look at a couple of ways that we can look at graphical representations of what's happening in human populations and see what we can learn about these factors simply from those graphical representations. So, those graphical representations are called age structure diagrams, or sometimes you'll hear them called population pyramids. So these show the proportion of individuals in a population of each age range and each gender. They show at a glance information about the age of a population, whether there are lots of young people or lots of older people. And this information can be used to determine whether a population is growing quickly, whether it's shrinking, whether it's stable. And as we move through this unit on population, we're going to talk about development stages of a country. And so the shape of the age structure diagram is also generally correlated with what stage of the demographic transition a country is in. So let's take a look at some of these age structure diagrams. Again, they're showing the proportion of individuals at various ages. Generally speaking, here on our x-axis, we'll have the proportion of, we'll have a percentage. Every now and then it will be actual raw numbers. So when we look at these, each bar represents an age bracket. So generally they're in 5-year groupings. So this would be 0 to 5, 5 to 10, 10 to 14, and then 15 to 19, and so on up the channel. You'll notice here that they're labeled in 3 different colors on these particular ones. The first 3 are what we consider pre-reproductive ages, meaning that that's before we reach the age of sexual maturity and are having children. The yellow is the reproductive age, which is 15 to 44. Here in the US, obviously, most people don't start their reproductive age until later, but biologically, reproductive age is reached at 15. And then post-reproductive age, which is 45 and up. They're also split into male and female. This is important when it comes to populations because the number of women able to give birth has a big impact on populations. So these 4 are showing us the 4 stages of populations. And those 4 stages are this first one where we have a really wide base and a really narrow peak. Tells us that this is a population that is expanding very rapidly. It has a high total fertility rate. It has a lot of people in the reproductive age stage. But we can also tell, because this narrows down so quickly, that this has a high death rate. And again, because there are so many more children of pre-reproductive age than there are people of reproductive age, this tells us that there's probably a high infant and child mortality rate. And also this big difference between this first bar, 0 to 4, and the second bar of 5 to 9 tells us that that's that high infant mortality rate. Deaths before age of 5 are all considered infant mortality. So this is a rapidly growing society, but it is one that has a high death rate, both overall death rate and a high infant mortality rate. If we look at this next one, this is a country that is expanding slowly. It still has this typical pyramid shape, but it's a much narrower pyramid. You'll also notice that the life expectancy is going up. This means this is a country with improved access to medical care, and it has a longer life expectancy. It does have a lower overall fertility rate, but you also see that the infant and child mortality is decreasing drastically. Our next pyramid is a stable pyramid. You'll notice that it does taper down, obviously, up here at the top, but the bottom part is relatively consistent throughout each age range. This is a population that is, generally speaking, not going to be growing because the fertility rate is at a replacement rate. And then we have this sort of inverted pyramid. This is a declining population because it has fewer people of reproductive age than people of post-reproductive age. So without immigration, this country's population is going to be shrinking. So rapidly expanding, this tends to be developing nations. Okay, so the examples we have here are Guatemala, Nigeria, Saudi Arabia. Countries that are expanding slowly tend to be industrialized or developed nations. So that would be countries like the US, Australia, and Canada. And in fact, currently the US is more likely to be over here in the stable population, like most of Western Europe, Spain, Portugal, and Greece. Then in the declining populations, these are what we sometimes term post-industrial nations. These are things like Germany, Japan, Italy. So they have declining populations. All right, so what can we learn from these population pyramids? We can look at a population pyramid and know whether a population is growing or shrinking. If it has a wide base and narrows quickly, it's growing quickly. If it has a wider base and top, it is growing. If it's narrower at the bottom than at the top, then it's going to be a stable population. By comparing those first bars, we can tell something about the infant mortality rates of a country. And as we're going to learn in tomorrow's lesson, we can learn about demographic transitions. And by looking at the population pyramids, we can determine what stage of the demographic transition a country is in. Okay, so a quick definition, we have this idea of population momentum. So a population momentum effect is the idea that the proportion of individuals in a population whose are of reproductive age determines whether a population is growing or shrinking. So if we have a more youthful population, it's going to continue to grow. An older population is much more likely to be shrinking. And again, we're talking about reproductive age and post-reproductive age. So even if the birth rate is only at a replacement rate, if there's a larger number of women of reproductive age, that population is going to continue to grow because births are going to outnumber deaths. Okay, so let's talk about that idea of a fertility rate. So when we talk about the total fertility rate, we are talking about the average number of children a woman produces in a population throughout her life. Okay, so again, this is average. This picture is showing a family that for the US is far from average. So in the US, this number, this fertility rate is actually 1.8. In the world, this number on average is 2.4. So on average, a woman produces 2.4 children in her lifespan. In the country of Niger, this number is 7.2, and in South Korea, it's 1.2. So that's the idea of total fertility rate. There's also this idea of replacement level fertility. So replacement level fertility refers to what total fertility rate is needed in order to keep the average number of deaths and the average number of births approximately the same in a country in order to keep population size stable. And so if we look, for example, at Japan, we can see that this black line represents fertility replacement level or replacement level fertility, meaning this is how many people would need to be born or how many children a woman would need to average having in her lifetime in order to keep their population stable. And you can see that over the last 70 years that population is decreasing because the total fertility is below replacement fertility. It's different in different countries. In countries with a high infant mortality rate, the total fertility rate is, or sorry, the replacement level fertility rate is going to need to be higher because the death rate is higher. In most developed countries, replacement level fertility is about 2 because we have high levels of income, high levels of industrialization, high levels of medical care, and plenty of food. In developing countries, on the other hand, it needs to be higher, on average 2.2 or even more, because of those high levels of infant and child mortality. So we're going to quickly look at world life expectancy. So you can see that here in the industrialized nations, that the life expectancy is very high, 75 or 80 or higher. Um, most of Asia, that it is still relatively high in the 60s, and then same for much of South Africa or South America, sorry. And then in Africa, that life expectancy is lower. And this has to do with access to reliable food sources and to adequate medicine and sanitation. And in Africa, a big piece of that is water. And you can see that correlation with infant and child mortality rates as well. Having a high infant mortality rate is going to bring the overall life expectancy down. Again, infant mortality rate is defined by the number of deaths before age 5. So the factors that affect life expectancy, infant mortality rate, and child mortality rate. A huge contributor is available health care and prenatal care. Another one is adequate food supply. And then, of course, potable drinking water. Many diseases in developing countries are from inadequate water supply or from contaminated water supplies. Good sanitation makes a big difference. Many diseases are carried by unsanitary conditions or increased by unsanitary conditions, and moderate or low levels of pollution. So when we put it all together, we can talk about quality of life. And one of the easiest ways to judge the quality of life in a country is to look at life expectancy and infant mortality rate. Put together, those two can give us an effective measurement of the quality of life in a country. Okay, so we'll continue with human population dynamics and talking about the demographic transition as we move forward. But if you have any questions so far about human population dynamics, just let me know.